Good evening. So the next topic, what we are going to discuss, the applications of BFS and DFS we are discussing. In that, we have seen very clearly how you can able to check is there any path is there from one node to another node. We verified very clearly. Next and after that, so we have calculated how many paths are existed from source to destination, and even we printed all the paths from source to destination. Now, sir, the next topic what we are going to discuss here is we have to detect a cycle in an undirected graph. Sir, if you take any undirected graph, in that undirected graph, is there any cycle are there or not? We have to check detection of cycle, sir. We have to detect the cycle. Okay, sir, if you want, I will take one simple example. Suppose consider I have a graph is there. Okay, so with 0 is one vertex, and then 1 is nothing but another vertex what we have, and from this we have another vertex is 2, and from this we have another vertex is there 3. And can you please confirm, is there any cycle in this graph? Can you please confirm, everyone? Is there any cycle in this graph? Please confirm. Yes, there is no cycle. In such cases, my expected output is nothing but false, sir. Suppose if there is a edge between this 1 and 2, if there is a edge between 1 and 2, now, yes, there is a cycle. Sir, what is that cycle here? If you observe, sir, is this is going to frame a cycle or not? Yes. In such cases, we have to return true, sir. In such cases, we have to return true. Sir, how you are going to consider this example? How we are going to solve this problem? Very simple, sir. Here, first I will maintain a visited Boolean array. So 0th node, that is 0th vertex, first vertex, second vertex, and then third vertex. Like this, I am going to take. Sir, now by default, every value is what, sir? False. By default, every node is not visited. Sir, we will start from a source. Let it be 0. We will start from 0. Sir, is 0? I am going to make it as visited. So true. Sir, next what we have to do is we are going to call this method by passing this graph and then visited array, and then which is the node that we are going to pass? 0 is nothing but a current node. Sir, we will find out the parent of each and every node. Parent means what? From which node this node came, that we have to detect. By using that parent, we are going to check. Sir, by default, for first node, parent is -1. Sir, this one is current node. This one is nothing but a parent node. Sir, why we are taking parent? When you are keep on traversing, if anywhere you got a parent, based on that, we are going to take the decision, sir. That is the reason. Sir, now it is a recursive call. We will call recursively. First, we will find out adjacent nodes for this current node, which is nothing but 0. For 0, which nodes are adjacent? Sir, 1 is nothing but adjacent, 2 is nothing but adjacent. Okay, for 0, 1 is nothing but adjacent, 2 is nothing but adjacent. So, two paths will be there. Okay, sir, first, since it is a recursion, I am going to call recursively. So, G comma V, that is visited vertex, and then 1 is nothing but the adjacent. Sir, who is the parent for 1? Parent for 1 is nothing but 0. Like this, we are going to get. This is nothing but a current node. This is nothing but a parent. Okay. Sir, next what will happen? We are going to traverse this one. Sir, 1 is nothing but visited. Of course, I will write in detail in our algorithm. Don't worry. Sir, next we have to check what are the adjacent nodes for 1. Sir, for 1, which are adjacent nodes? We have 0 and then 2. Two nodes are there. So we have 0 is there and we have 2 is there. Okay, we have 0 is there and then we have 2 is there. Sir, now for 0, immediately you can stop. Why? Because it is equal to this parent. That means what? We are in the same direction. So for 1, for 0, we find out 1 is nothing but adjacent, Again for 1, 0 is nothing but adjacent means reverse we are taking. So this current node 1 for his parent is 0. Again, if it is adjacent, no need to traverse reverse back. That's why we are going to stop. Sir, then what is another adjacent? This link got deleted. I mean, this one we are going to ignore. What is another node? 2 is there. Okay, 2 is there. Now what we have to do? Sir, graph we are taking, vertex we are taking, and then here current node will become 2, and parent, who is the parent for this? Previous current node, which is nothing but 1. Here previous current node, which is nothing but 0. Like that we will get. Sir, now which is current node 2? Who is the parent node? 1. For 2 which are adjacent, sir, we have 0 is adjacent. Next and after that 1 is adjacent. So next and after that 3 is adjacent. So 3 times recursively it is going to call. Sir, when 0, okay, when you got adjacent node as a 0, sir, is it same as a source node or not? Yes, it is same as the source node. We have to check current nodes. Sir, is it same as a source node or yes? Sir, then we can immediately return true saying there is a path. Okay, there is a path. Okay, sir, here 1 and then parent node, both are same. That means in this direction only we came. Again, we should not check this one. So what we have to do in this case, it is going to fail. Of course, this won't execute because here itself we are going to return true. There is a cycle. There is a cycle. Okay, I think at least some points you got, sir. Can you please confirm, is the theoretical process how it is going to work? Is it clear for you people, guys? Please confirm. Is it clear? I request everyone to please confirm. Right. So if there is no this path, if there is no path, then it will be moving continuously like this. If you want, you can see just one simple example I will draw. Suppose consider 0 is there. Okay, so for this adjacent node is nothing but 1, and for 0 another adjacent node is nothing but 2. For 2 adjacent node is nothing but 3. Like this we have. How it is going to call for first time? It will call for graph comma, so sorry, so graph comma, so visited array, and then 0. We will start from 0, and the parent is nothing but minus. Sir, which are adjacent nodes for 0? So 1 and then 2. Okay, next here we are going to call, so graph comma visited, and then sir, which will be the current node? 1 is nothing but current node. Who is the parent? 0 will become parent. For 1 which are adjacent, we have only 0 is there. Okay, now this node and parent node both are same, so it will stop. It won't do anything, sir. It is not going to return false. It won't do anything. Okay, so next, what is the next step here? Sir, we have to go with another adjacent node for 1. Is there any other adjacent node? No. Then it will come back, sir, another adjacent node is nothing but 2. So graph that visited array, and then current node will become 2, and parent will become what? 0. For 2 which are adjacents, sir, we have 2 nodes are there. One is nothing but 0, another one is nothing but 3. Sir, if 0 means it is equal to the parent, do nothing, not returning, do nothing. Okay, do nothing. Sir, then we are going to check. For 3, so we have graph comma visited comma current node will become 3. So its parent will become 2. Okay, current node is nothing but 3. Parent is nothing but 2. Sir, here current node is what? Sorry, parent node is what? 2. Sir, is it equal to source node? No, right? In this case, it is going to return false because there is no other continuation. Okay, so like this we are going to take. Sir, if parent and current node are same, we are not going to do anything. See here, there are two cases are there. First one is nothing but a parent and a current node. Both are same means do nothing. Do nothing. We are not going to do any process. We will continue. Okay. And sir, what is the next case? Suppose, okay, suppose if parent and then Okay, suppose if a parent and then mm, so if a destination, okay, destination and then which is not equal to parent, if destination is not equal to parent, destination is not equal to parent, that means it is equal to source. So that means what will happen in this case, sir, it is going to return true. It is going to return true. Okay, so like that we are going to write the cases in our program. Okay, so I think you people got some clarity, visualization clarity, how to detect a cycle in undirected graph. Can you please confirm, is this concept is clear for you people? Don't worry, in the program I will go in detail. Can you please confirm? Clear up to this? Right. Now let us see how to implement this code. Let us see how to implement this code. Now, sir, I want to create a graph. Okay, I want to create a graph. So with how many vertices? Let us take our previous example. Sir, 4 vertices. So undirected graph. So 0 to 1, there is a path. 0 to 2, there is a path. Okay, next and after that, if you take 1, so 1 to 0 path is there, it will be added automatically. 1 to 2, there is a path. And if you take 2, 2 to 3, there is a path. First, let us print that graph. Whether our requirement is satisfied or not, we will get clarity. Let us see. Right. Sir, what is the graph that we have taken? So 0, 1 node. Okay, next and after that, 1 other node. So next and after that, 2 another node. Next and after that, 3 other node. Sir, now you can able to see. So 0 is connected to 1 and 0 is connected to 2. Then 1 is connected to 0 and 2. 1 is connected to 0 and 2. Next, 2 is connected to 0. 2 is connected to 0. 2 is connected to 1 and 2 is connected to 3. So 3 is connected to 2. That's all. Okay, this is nothing but graph. Yes, perfect. My graph is okay. Now you have to write a code for this. What is that code? Sir, we have to detect a cycle, sir. System.out.println of, listen carefully. I'm going to pass a graph G, graph dot. So detect cycle, detect cycle. I will pass a graph. It has to return either true or false. In this example, is there any cycle? Yes, we are going to get a true. Now see what will happen. Now see what will happen. We have to define that function. So I am taking static boolean. What is the function name? Detect a cycle, which will take a graph. Internally, it is going to maintain one boolean array to maintain the visited status is equal to new boolean. Okay, new boolean of, I am going to take a g dot v. How many vertices are there? With that, I am creating an array. And we have to visit each and every vertex, right? That's why I is equal to 0, I less than graph dot vertices I plus plus. In this, if that node is not visited, okay, if that node is not visited, then I'm going to check. So detect cycle, detect cycle util, I will call one more function, detect cycle util. So which is going to take your graph and then your visited node, and here I will become your main source, and then -1 default parent value. So if it is returning true, then I will return true. So if there is no cycle, I'm going to return false. But we have to write utility function, because for every node I am checking. For every node I am checking. I will start traversing from every node, and is there any cycle or not, it will decide. Okay. So if at least one cycle found, it will return true. If cycle is not there, it will return false. But for every node, we will check for the worst case. So now we have to take a static boolean another method, detect cycle util, which is going to take a graph G and then a boolean array with name visited. So next and after that integer current node and integer, so parent node. Like this I am going to take. Now we have to implement our main code, sir. Let us see how you can able to implement this main code. What is the first step? Visited of your current node, I am going to make it as a true. Listen carefully, parallel I am going to do the execution. So consider this is nothing but my visited array. So how many nodes are there? So 0th node, first node, second node, and then third node. By default, all the values are false. All the values are false. Now 0th node we are passing. 0th node we are passing. We are calling graph, comma, visited, comma, current node will become 0 and -1 for I is equal to 0. So here this is nothing but a current node. This is nothing but a parent node. Sir, first what we are doing, that 0th node we are making it as a visited. Sir, after this, what is your next activity? After that, I have to find out the adjacent list, right? So that I'm going to take one temporary list, so which is going to get adjacent nodes for this current vertex. Okay, sir, for this node which are adjacent for 0, which are adjacents, sir, we have one is there, we have one is there, and then two is there, right? These two will come. So that means the path will be two times for okay. So for 0, adjacent nodes are nothing but 1 and then 2. Okay, so we are going to get for 1 and then 2. Like this we are going to get. Now, sir, every time we have to run, right? So for each loop I'm taking, for each edge e value from this temp, then first check, sir, is visited of e dot destination, is it visited or not? We have to check. Sir, what is the destination here? 1. Is the node 1 is visited? No, it is not visited. That means what? False. Not of false means yes, it is not visited. If it is not visited, then what we have to do? We are going to call detect cycle util by passing that graph, comma, visited array, comma, next and after that e dot destination, your parent will become current, sir. Like that we are going to call. Sir, now what will happen? Observe carefully. Detect util I called. Sir, is 1. Is 1 is not visited? Yes, it is not visited. Then I am going to call this function that is nothing but g, comma, that visited array, comma. Here destination is nothing but what? 1. And then current node will become what? Parent. What is the current node here? So 0. Like this we are going to get. Now, sir, for this again it will call the same. Visited of current. In this current is nothing but 1 and parent is nothing but 0. Sir, is this node is visited? No. Then we have to make this one as a true. Next, what we are doing, we are finding adjacent nodes for 1. For 1 which are adjacent nodes, for 1 which are adjacent nodes, so 0 and then 2. Okay, so 0 and then 2. Like this we are going to get. Sir, it will check. So is 0, is it visited? Is visited of 0? Sir, it is true. Not of true will become false. Sir, if it is false, what we have to do? If it is false, what we have to do? We need to check one more condition. What is that condition? Visited of e dot destination. Sir, that destination should be visited. What is the destination here? 0. It is visited, yes. And e dot destination is not equal to parent, is not equal to parent. Sir, is this e dot destination is not equal to parent? No, it is equal to parent. So else if we are going to return true, we are going to return true. That means there is a path, there is a path. Otherwise we are not going to do any activity. Sir, this condition is also not satisfied. That means what? Simply continue. I am not going to write anything. Sir, I can say this is nothing but case 1, sir. Okay, this is nothing but case 1. And I can say this is nothing but case 2. And what about case 3? Do nothing. Do nothing. So it will be repeated. It will be repeated. Again, what will happen? Here we are not doing any activity. So it will call back and it will call for this. Now, visited of 2 will become true. Sir, next, try to identify adjacent nodes for true. Sir, for 2 which are adjacent, so 0, 1 and then 3. For 2 we are going to get, so g of, okay, so g of visited, current node will become 2, parent will become 1. For this, how many values we are going to get? So 0, 1 and then 3. 3 nodes are there. For 0, what will happen? Is it visited of 0? 0 is already visited. This condition fail. Sir, visited of 0. Yes, true. And e dot destination. What is the destination? 0. Is it not equal to parent? Yes, it is not equal to parent. Then it is going to return true, sir. It is going to return true. That means there is a path. Okay, it is going to return true. That means what? There is a path. That means what? We traveled from 0 to 1 and 2, and we came to know that it is nothing but 0. For 2, it is parent is nothing but 0. Yes, there is a path. Immediately it will stop. Suppose if there is no parent, then again this process is going to be continued. Like that we will have, sir. So let us cross check really whether we are getting or not. And here, if finally if this condition is true, then we are going to return. Sir, if this condition is fail, at last what we have to do? So if all cases are gone, at last we are going to return false. That's all. Now we will see, is there any cycle or not? Maybe 1 or 2 compilation errors will be there. We will see. So what output we are expecting? True. Yes, there is a path. Sir, I will do a small modification in this. I will do a small modification in this so that my output should be false. Okay, let us check what is that modification. So here, the modification which I'm going to do is, sir, I will delete, okay, I will delete this particular link, sir. I will delete this particular link. Now see what will happen. If I delete that link, okay, if I delete that link, first we will run, sir. Okay, 0 to 1 path is there. So 0 to 2 path is there. 1 to 2, I am hiding this. Sir, 2 to 3, yes, edge is there. Only 3 edges are there. Now let us run this program. Is my algorithm is working properly or not? Yes. The output what we got here is nothing but false. But let me dry run this code so that we will get at least some idea whether it is working properly or not. So have a look once. I will trace this algorithm. Sir, what is the first step that we have to do? We have to maintain a visited array. Okay. So with 0th node, first node, second node, and then third node, by default, all these values are nothing but false. First, I am calling graph visited array. Current node will become 0. Parent will become -1. Okay, parent will become -1. Sir, this is current, this is parent. Make this current node as visited. Now, which are adjacent for 0? So we have 1 is adjacent and 2 is adjacent. Now take 1, take 1. So graph comma, so visited array comma, current node will become 1. Its parent is nothing but what? Previous current node, which is nothing but 0. Now you have to find out adjacent nodes for 1. Which are adjacent nodes for 1? We have only 0. Okay, we have only 0. Have you observed? Visited of 0. It is nothing but true. That means what? This condition is not satisfied. Sir, visited of 0 true and e dot destination is not equal to parent. No, it is equal to parent. Then case 3, I am not going to do any activity. Do nothing. Sir, is there any other adjacent for 1? No. Then reverse back. Then we are going to take second one. Sir, for second one, which are adjacents? Graph comma, vertex comma, 2 comma 0. So here 2 will become current. So parent is nothing but 0. For 2, which are adjacent nodes? 0 and then 3. So 0 and then 3. Two possibilities. If you take 0, then what will happen? This is the destination, right? So again check visited of e dot destination. Okay. I think while coming this value will become true. Okay. Sir, visited of 0. Is 0 is visited? Yes, true. Not of true means false. This condition not satisfied. Else if it is true, and destination is not equal to parent, but destination is equal to parent. That means there is no path. Okay, that means there is no cycle. So do nothing. It will stop here also. Now check here. We have only this possibility. Now what is the condition? Sir, is not of e dot destination. Sir, is this one is visited? Is this one is visited? No, not visited. Then what we have to do? Not of visited. One second. I think for this again a call will be there, right? So 0 comma. Okay, let us check. So visited of e dot destination. I think we have to make a call, sir. We have to make a call. G comma. So v comma current node will become 3, parent will become 2. So for 3 which are adjacents, only 2 is there. Now call back. Sir, visited of 3 will become true now previously. Now adjacent nodes, not of visited of destination. Here destination is 2. Sir, is it visited? Yes, it is already visited. So this condition not satisfied. Sir, visited of destination. Yes, it is true. And e dot destination. Sir, what is the destination? 2. It is not equal to parent. It is not equal to parent, but it is equal to parent. So do nothing. It will come back. So again, this condition is not satisfied. Sir, come back. Is there any other adjacent nodes for this? No. Sir, is there any adjacent nodes for this main 0? No. Task completed. That means all the edges we have traversed, but there is no possibility. So return false. Okay. Immediately it is going to return false. Okay. I think you people got a very clear clarity how you can able to detect a cycle. So in this undirected graph, can you please confirm everyone is the concept is clear for you people, friends? I request everyone to please respond. Clear? Clear, please confirm. Right. So next one. Sir, what is the next concept? You can imagine the next one is the same like this. We have to detect cycle in undirected graph. What is the destination node? I'm not getting that point. Destination node in the sense which is adjacent to this. For example, if I am taking a graph like this, 0 is connected to 1 and 0 is connected to 2 and 2 is connected to 3. Suppose if you start from 0, which are adjacent to this 1 and then 2, right? When we are working with 1, so here current node is nothing but 1. Okay, current node is nothing but 1, which are adjacent to 1, 0, right? Then this 0 will become destination. Okay, and for 2 which are adjacent to 3, 2 will become current and 3 will become destination. But when you are working from 0, adjacent nodes are these 3. So these two, this will become current and this will become destination. Are you getting my point? Destination in the sense source is nothing but 0, destination is 1. Got it? Because you know very well here we have defined destination, right? So next one, we have to detect a cycle in directed graph. Sir, it is very simple in undirected graph, but it is a directed graph means you have to maintain another two conditions, sir. Anyway, I will explain this. First, I will take one simple example so that we can understand. So consider I have one example is there like I am taking 0. This is nothing but one node, that is nothing but one vertex. So from 0, we have a connection to 2. Okay, we have a connection to 2. And from 0, we have a connection to 1. We have a connection to 1. And from 2, we have a connection to 3. And from 1, we have a connection to 3. Can you please confirm, is there any cycle in this graph? Everyone, please respond. Is there any cycle in this graph? Please check clearly and tell me. Yeah, there is no cycle. So what output we are expecting? False. And assume I have node 0 is there. Okay, node 0 is there. Sir, it is connected to 2. It is connected to 2 and it is connected to another node called 1. And from 2, we have a connection is there for 3. And from 3, we have a connection is there to 0. Now, have you observed here? Is there any cycle? Yes. So this is nothing but a cycle what we have. Okay. This we have to detect. If it is undirected graph, in both cases, cycle is there. But if it is a directed graph, there is a direction. Sir, carefully you have to visit everything, sir. Anyway, don't worry. Step by step, I will explain with the help of algorithm. Okay. Sir, can you please confirm, is these two examples diagrammatic level, is it clear for you people? Right. Now we will see algorithm for this, how it will be. Sir, it is also same, sir. First we will prepare a graph. Okay. Graph G is equal to new graph of 4 vertices are there. Okay. Consider the graph is nothing but something like this. We have 0 and which is connected to 2 and which is connected to 1 and which is connected to 3. Like this we have. Like this we have. First let me construct this graph. So add directed edge. Okay. Sir, first there is a edge from 0 to 1. There is a edge from 0 to 2. And then there is a edge from 2 to 3. There is a edge from 1 to 3. That's all right. Now you have to check detect cycle. Otherwise, I will change the name in the place of detect cycle. So is a cycle. Is there any cycle? The output what we are expecting is nothing but a false, sir. Let me do. I think these two methods we have to remove because it is not for undirected graph. Sir, I will take a method static void is a cycle. Is a cycle which is going to take a graph G, and listen carefully. Here I am maintaining two Boolean arrays. One is for visited. Okay, one is for visited, which is going to have how many values? It is going to have G dot V vertices. Next, I will take another Boolean, which is nothing but something like a stack to maintain that traces. Okay, it is also a Boolean array. Don't feel that the stack means our stack. No, no, it is a Boolean array. Okay, sir. Now, what is our next step? For integer I is equal to 0, I less than the number of vertices, I plus plus. Every vertex we will check. If it is visited of I, if it is not visited, then we have to check is a cycle. Okay, is a cycle util by passing that graph. Okay, next and after that, yes, we will pass that visited array and then we will pass that stack also. Okay, we will pass that stack also and then I can say that I is nothing but a current. I is nothing but a current. Like this I will pass. If it is returning true, then true. Otherwise it is going to return false. Like this I am going to maintain. Sir, next, what is another thing? So static Boolean. So we have to create. So is a cycle util, which is going to take a graph G. And what is the next one? Boolean array visited, Boolean array visited, and one more Boolean array stack. So then integer current node, current node. With this we have to develop. First I will write the logic. First we have to take visited of your current node will become true. At the same time, sir, I'm going to take stack of that current node is also true, visited. So then I will find out what are the adjacent nodes are there for this vertex, which I am going to store it in temp. Okay, so graph dot adjacents dot get of current. Now for each edge E present in this temp, I'm going to do certain activity. So if a stack of, okay, if a stack of E dot destination. So if it is visited, then I will return true. Okay, so if it is not visited, I am going to check visited array e dot destination is at e dot destination, and is there any cycle? Is there any cycle for this graph comma visited array comma stack comma, and then so current node will become what? E dot destination. Is there any cycle or not? We have to check. If these two conditions are satisfied, then return true. Then return true. Then listen carefully. We have to do backtracking. What is that backtracking? Stack of that current node is there, right? I am going to assign that value to false. This is for backtrack. This is for backtracking. Okay. So in previous case, directly we can decide the result, but here compulsory backtracking is required. Sir, maybe it is hard to explain this code. Just have a look once. Okay. Now listen carefully, sir. Step by step I am taking. Sir, what is the first step here? What is the first step here? We are going to take two arrays. We are going to take two arrays. This is nothing but visited array. How many nodes are there here? Four nodes. 0, 1, 2, 3. 0, 1, 2, 3. Another array is also there, which is nothing but a stack. Okay. So 0, 1, 2, 3. So this is nothing but a stack. This is nothing but visited. Of course, you know very well, by default, all the values in these two arrays are nothing but false. All these values are nothing but by default, it is false. Sir, first, when I is equal to 0, when I is equal to 0, it will work. And even for I is equal to 1, it will work. I is equal to 2, it will work. I is equal to 3 also, it will work. Suppose if it is not returning true, it will check for every node. If anywhere while checking, if any one of these conditions satisfied, then it will return true. Otherwise, it will verify all these nodes and it is going to return false. That's why this is a bit tricky question, sir. Okay, we have to check all possibilities. Sir, first time checking I is equal to 0. I is equal to 0. Sir, is it visited? Is that 0th node is visited? No, it is not visited. Then call utility function. Now what will happen? For 0, I'm tracing, sir. For 0, I'm tracing. Observe carefully. For 0, sir, what is the first step? Visited of 0 will become true. Visited of 0 will become true. Yes, this value is nothing but true. And this value is also right in both the cases. Sir, what is the next step? So linked list. We are going to create a temporary which are adjacent nodes for this 0. Which are adjacent nodes for this 0? We have 2 and then 1. Okay. So 1 and then 2. Two nodes are there adjacent to this. Okay. Then first I will check. Sir, first which value it is going to take? This one. This one. First this one. Sir, destination is nothing but 1. Is a stack of destination, is it visited? No. Then visited of destination. No, it is not visited. Okay, it is not visited. Sir, then what we are doing? If this condition is false, not of false will become true. Then is cycle I am calling G, comma visited array and then stack destination. What is the destination here? 1. I am passing. Then again it will call the same function. Sir, visited of current. Now current is 1. So it will become true. It will become true. Sir, next term, stack of current. It will become true. Please observe my careful. Then what will happen? It will find adjacent nodes for 1. Which are adjacent nodes for 1? We have only one adjacent node, which is nothing but 3. Sir, next stack of E dot destination. Sir, is it visited? No. Sir, visited of E dot destination. Yes, it is not visited. This entire condition will become true. And it will call is a cycle. Is a cycle again. It is going to call is a cycle. Sir, what this is a cycle is going to do? Sir, it will call again by passing G comma. So visited comma stack comma E dot destination. What is the destination here? For one destination is nothing but 3. Okay, next it will call sir, again visited of current 3 will become true, and stack also will become true. Sir, next what it is going to do? So adjacent nodes for this 3, is there any adjacent nodes? No. That means this for loop is not going to execute. Stack of current. In this case, what is the current? 3. That will become false. That means what? It is not visited. It is not visited. So it will make this one as false. Okay. Sir, next and after that, one cycle got completed. That means what? Backtracking. Now your current node is 1. Sir, this condition is also satisfied, right? Then that current node is also going to reset to false. So this current node is also going to reset to false. Now this will become false. Okay. Sir, next it will go back here. Okay. Again, it will check for 2. For 2, what will happen? For 2, what will happen? Sir, is the current node 2, is it visited? We have to make this one as visited. Okay. Then try to find out adjacent nodes for 2. Which are adjacent nodes for 2? I think we have only 3, sir. We have only 3. So graph comma, we have 3 is there, right? So check stack of 3. Is it visited? No. Then visited of 3 stack. Sorry, in this. Sir, is it visited? Yes, this one is visited. Okay, this one is already visited, right? 3 already visited. Somewhere here it is visited. So this will become false. Stack of current. Sir, what is the current here? I think 0, right? That 0 will become not visited. That 0 will become not visited. Okay. Next, sir, the complete trace for I is equal to 0 got completed. Now what will happen? I is equal to 1. Okay, I is equal to 1. For I is equal to 1, listen carefully. Sir, is visited of 1. Is 1 is visited? Yes. Is 1 is visited? Yes. Completed. Sir, I is equal to 2. Is 2 is visited? Yes. Sir, I is equal to 3. Is it visited? Yes. Then for loop got completed. At last it will return false. There is no cycle. Sir, somewhat hard to understand, but once if you trace out, you people will get. Sir, we it is sufficient for taking visited. Why we need stack? Because of backtracking. We can't maintain 2, right? Okay, suppose if there is a path from here, so to come back directly, we should not use this visited because it is not a directed graph. Sorry, it is not undirected graph. Compulsory to maintain these visited nodes, we need one array, I mean one Boolean array, and to make recursive calls, to make trace back, we need another array, which is nothing but a stack, something like stack I am using. The word stack I am using internally, it is nothing but Boolean array only. Okay. I think at least somewhat you got a clarity, sir. Can you please confirm? Is it clear up to this? At least some idea. Please confirm. Right. Yeah, you have to trace back, sir. But let me check whether it is going to return false or not, because maybe there is a chance of getting errors also. Incompatible type, unexpected return type, Boolean. Which one? I think this one is going to return Boolean. And this one is not going to return any value, right? Is it going to return? But it may expect again one return type, missing return statement. I will do one thing. Simply I will return. I'm not going to write anything. Simply I will return. Or we should not return any false here. Okay, we will see. So what answer we got? False. There is no what you can say edge. I mean there is no cycle. But I need to check one more graph because some cycle, with the cycle we will take some graph so that we can get clarity. Okay, so previous graph, yes, it is there in my book. So 1 to 0, and from 0 to 2, and from 2 to 3 like this we have, and 2 to 3 and 3 to 0 and 1 to 2 and 0 to 1. Try to write this 4 edges. 0 to 1 there is a path, and 0 to 2 there is a path, and 2 to 3 there is a path, and from 3 to 0 we have a path. From 3 to 0 we have a path. So my expected answer is nothing but true. But let me check whether we are getting or not. Yes. Is it correct? 0 to 1, 0 to 2, and 1 is not connected to anything. 2 is connected to 3. So 3 is connected to, yeah, perfect. Yes, it is working fine. So I think you people got very clear clarity how to detect the cycles in directed graph and undirected graph. Can you please confirm everyone? Is the concept is clear for you people? Yes. I request everyone to please confirm. Clear? Right, sir. So that's all about today's session. Tomorrow we are going to discuss about, okay, so which algorithm? Sir, shortest path from source to all vertices. Okay. So shortest path from source to all vertices. So how you can able to calculate shortest path from source to all vertices? Tomorrow we will discuss. Okay. And this Saturday and Sunday we will have a class. So timings around 2 hours I will take, sir. So 7 to 9 like that I'm going to take this Saturday and Sunday. So maybe additional 2 days is required because in graph I'm trying to get maximum concepts. So that's why graphs will be finished maximum by Saturday or Sunday. Okay. So then additional 2 or 3 days I will take some extra time and then I will wind up. Okay. Right. Thank you, sir. Vishal, sir, I will conclude that. Okay. Once if the graphs got finished on Saturday, okay, then I will take red black trees and AVL trees, these two on Sunday. So if it is not completed, I will cover red black trees and AVL trees later, and also divide and conquer algorithms because it is a theory topic. Already we covered that. These two I will take on extra class. Remaining things I will continue. Okay. I will inform you that after completion of graph only we will move to any other topic. Right. Thank you, sir.